by constant. And we discuss one example with which you are already familiar for decrease by constant factor, and the example which we have discussed last time, that was binary search algorithm. So do you have any question till the topic which we have covered last time? Okay. Have you guys identified your mistake in midterm 1? Please be careful for the coming exam, and it will be very easy to attempt the exam if you cover the all contents which are available on the slides. This file is taking too much time to upload. Please wait. Can you see the slides? Which question? Let me open the exam. Maybe statement might be a little bit different, so that's why you get confused. Let me open the exam and then I will tell you. Okay, fourth question, how they can write that none of above? Where did you see this question? In same question in the book? In which book you have this question? In the slides. Can you tell me the slide or the lecture number in which you have seen this exam, this question? So I can reconfirm it. Because the statement is very straightforward, that the function g is an upper bound on function f if and only if all x. So for all x, this g of x will be the upper bound, and it is only possible if f of x is less than equal to g of x. So it is written in other way, or otherwise it's the same. The relationship should be fx must remain less than g of x into c. Okay, that was a complete definition. Obviously, in this MCQs they are just relating the general relation. Okay, otherwise, according to the definition, many things are missing still. For example, it is not defined what will be the value of C, what is N naught. N naught must be less than, for all N greater than equal to N naught, it should be true. So there are many other associated conditions, but in generally speaking, upper bound will be defined if the function remain less than g of x. Is that clear? Okay, so last time we started the topic of decrease by constant factor, as mentioned earlier in the introductory lessons of decrease and conquer. We discussed that the meaning of decrease by constant factor is that for every iteration, the problem size is being reduced by a common ratio. And you, as you have observed merge sort algorithm, or you have seen the binary search algorithm. Okay, and usually in most of the cases, this constant factor design always have a factor of 2 to reduce the problem size, but it is not the basic rule that how you can divide the values. Okay, so binary search has the running time log n. We have discussed it last time, and this is the how you can prove it, that the running time is log n. Now we are moving to the next case study, which is fake coin problem. Again, this algorithm is designed on the basis of decrease by a constant factor. So the problem statement is that you need to solve a problem that you have some number of coins and one of the coin is fake. Okay, so for example, you have 10 coins and one coin is fake, but they are very identical. You cannot look at them and you cannot decide whether which coin is fake. Then how you can decide that this particular coin is fake? What could be the brute force technique to solve this problem? Anyone? What is the brute force technique or exhaustive searching technique to solve this problem? How you can solve it if you are following exhaustive search or brute force technique? How you figure out which coin is fake? Anyone? The problem statement is that we have n coins. Okay, by looking at the coin you cannot decide. Okay, their shapes are very same, they are very identical, but fake coin is lighter as compared to the other one. Okay, now if you have 10 coins, how you can figure out which coin is the fake coin if you are following brute force technique or exhaustive search technique? You will calculate the weight. It means you have to weight all values, all coins. Okay, so it means how much time it will take to figure out which coin is fake. You have to compare it with all values. Okay, so if you pick one coin and compare it with rest of all coins one by one, after n iteration you can decide it. Is there any efficient way to solve this problem? Can you search it faster? How? Guessing is not, it will not give you a surety that you will search it every time within that number of iterations. We have to devise some technique that you can judge and find the coin speedily. Yes, divide them. And how you will divide it? By a constant number. And usually when you are designing an algorithm, decrease by a constant factor. What is that factor? Usually that is 2. Okay. So the idea is very good. Your idea is fine, that you have to divide those coins into 2 groups and put it on a weighing scale. Now there are 3 possibilities. One is both sides are stay same. So it means no coin is actually fake. But if it is surety, you have a surety that one of the coin is fake, what will happen? Any one of the side will come down. Is that clear? So if right side comes down, it means the fake coin is existing in left side, and if left side is coming down, it means the fake coin is existing in right side. Is that clear? So ignore half of the values which are heavier, and again split it into 2 group for the rest of the coins and do the same thing. And in this way you will keep on reducing the problem size by factor 2. Is that clear? Now if the values, number of coins are in the form of 2 raised power n, what does it mean? If the number of coins are 2, 4, 8, 16, 32, 64, 128, 256, then these values can be written as 2 raised power something. Okay? For example, 1024 can be written as 2 raised power 10. These are the number which can be divided equally till the last coin. But what will happen if you have odd values or any other number then which can be written as 2 raised power 10? Then what you have to do? For example, the number of coins are not 10, number of coins are 11. Then what you will do? No, if you divide it 6, 5, then definitely 6, the side which has 6 coin, they will be heavier. Then you can, even though the fake coin is there, no, no, no. If you have 11, then you cannot divide 4 and 5. You understand the situation? So if you have 11, then the solution is make 2 piles of 5, 5, and you will left with 1 coin. Now, when you weigh those 5 coins on both sides, there are 3 results, that whether they are equal. If they are equal, what does it mean? The 11th coin is fake, which you have put it separately. Second possibility is right side is lighter. So it means the right side, if right side comes down, it means left side is lighter. So the fake coin is on the left side. And if left side comes down, it means the fake coin is on the right side. And you will ignore the other side as well as the coin which you have taken out separately. You understand this situation? Do you get this point? So it means if you have the number of coins can be written as 2 raised power n form, which are 2, 4, 8, 16, 32, and so on, then there is no issue. You will keep on dividing by 2 and it will divide it into equal half. But if the numbers are simple even, or even if the values are odd, for example 19, then what you have to do, this will, in first iteration it will be divided into 5, 5, but later on it will turn into odd values. So whenever there is odd value, what you have to do, you will make two piles of, for example, 9, 9, and there will be one coin left. In this case, if these two piles are equal in weight, then the separated coin is fake. Otherwise, any one of the side will be lighter, and whichever the side is lighter, that side has a fake coin. And you will repeat the same thing again. In rest of 9, again you will divide it into 4, 4, and keep one separate. If they are same, then it means this separate coin is fake. Otherwise, any one of the pile will be lighter, and whichever the pile is lighter, that will be picked, and it will be divided into 2, 2. Then it will be divided into 1, 1. In this way, you will search the fake coin speedily as compared to the linear approach in which you have to compare the coin one by one. Is that clear? As we are decreasing the problem size by a constant factor of 2, that's why this problem can be solved using decrease and conquer. Any doubt? Okay, so this fake coin problem, and the main statement is solved through the decrease by constant factor strategy. If you have n identical looking coins, identify the one which is fake. How you can identify the fakeness? That can be only determined by the weight. So we have this assumption that a fake coin will be lighter, even though by looking you cannot distinguish it, but its weight is lighter. So what is the idea? You need a balance scale on which you can put two set of coins. So if it is tipping to left, it means the fake coin is on the right side, and if it is tipping to the right, it means the fake coin is on the left. And if it is staying even, then it means the separated coin, in case of even, that coin will be the fake. Or if they are staying even, it means none of the coin is fake in that pile. Is it clear? And in case of odd, what you have to do? You will keep on dividing into two equal size of group, equal number of values, and you will left with one extra coin. And do the same thing that if they are equal, then the separated coin will be definitely fake coin. Now, this process which I have declared now and explained to you, whether this implementation is recursive or iterative. You understand the question? So the answer to this question is, this algorithm can be implemented in both ways. We can implement iteratively, we can implement recursively. Okay, this is the question for implementation. The process will be repeated again and again. How you will achieve the repetition, that depends on your own design. But as we have discussed in 204 and later on, the recursive approach is more efficient to write the code for the complex calculation as compared to iterative. So we will preferably write it in a recursive way. Is that clear? So by nature, you cannot decide whether it is a recursive or iterative. When you write the algorithm, then you can decide. Okay, for example, if I write this algorithm recursively, can you write down the recurrence relation for this process, which I have just described? Why 2, Ahmad? Why you are picking 2 tn by 2? Whenever you are repeating, you are ignoring half. No, 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 no. We are making two group, but recursive call is applied only on only one side, isn't it? We are just ignoring the other half. So why you are writing 2 Tn by 2? Your attempt is fine. You have to write only Tn by 2 plus 1 because we are picking only half. It is very similar to binary search. Is it clear? So be careful when you are writing the recurrence. There are very minute things which you should focus when you are writing a recurrence for this one. So this fake coin problem, you are making two groups, but recursive call is applied only on one portion. That's why it's when you are writing a recurrence, Wn will be equal to W of n by 2 floor plus 1. And if you have only one coin, then you do not need any comparison. Then it will be 0. You cannot compare it. Otherwise, for every recursive call, you have to make one comparison. And if you simplify, it will be log n. This is the same recurrence which we have discussed for binary search. Remember, the last time we have solved this recurrence. This is the same as of binary search. Any doubt? Okay, now your exercise for the fake coin problem is that in given algorithm, you have to divide the coins. For example, if you have coin 10, 20, then it will be very easy. But if I say that we have a special kind of weighing scale which has 3 portions, so it means you have to divide the coins into 3 groups. Is that clear? If you divide the coin into 3 groups and you solve this problem, obviously making 3 groups will enhance the it will reduce the running time and it will enhance the efficiency. Okay, so now your task is you have to write a recurrence for this solution when you have divided the group coins into 3 groups, and then solve it and prove that its efficiency will be theta of log n base 3. This is your exercise. Is it clear? So you have to write a recurrence and try to solve it. And your solution must be theta of log n base 3. This is your exercise. You can do it yourself, okay? Now coming to the next case study, which is called Russian peasant multiplication. If you have large number which you have to multiply, generally speaking, when we are solving a multiplication problem, nowadays it is very easy. Computers are available, calculators are available, but this technique was introduced quite earlier, in early days when you do not have a huge memory of the computation. So this was the Russian scientist who invented this technique of multiplication of large integer numbers. In this algorithm, again, we are using that decrease and conquer approach, using the variant of decrease by constant factor. Although this algorithm is not much efficient, but at least it is using the design approach which is called decrease by constant factor. That's why it is included in your content. If you look at efficiency wise, this algorithm will be not much efficient and not very much appreciated on the efficiency scale. Is that clear? So basic idea is that usually speaking, the human can learn the table of smaller values. For example, if you have to memorize the table of 389, obviously it will be very difficult as compared to memorize the table of 2 to any length. Is it clear? If someone asks you to memorize the table of 753, that will be very difficult as compared to memorizing the table of 2. So basic idea was that with having the limited table knowledge and trying to multiply the bigger integers, how you can solve it. It means you will convert that problem into a problem of either multiplying by 2 or dividing by 2. How it is possible? See, if we have two integer number n and m, which are being multiplied with each other. Okay, for example, n was 785 and m was 365. So if you have to multiply these two numbers, definitely multiplying verbally it is difficult. So what was the technique? If n is even, divide n by half. So making half is easier. So you need only table of 2 and multiply m by 2, and again it is a matter of table of 2. So if you twice the number m and half number of n, what will be the if you simplify it, it will be equal to n into m, isn't it? Is that clear? So it means every number can be converted into the form of table of 2. This was the basic principle. And if n is odd, then what you have to do? Subtract 1 from n because it was odd. Then you cannot make it half exactly. So n reduce 1 from here, n and divide it by 2. Again you are making half. And then multiply 2 into m. That is twicing a value. And add the value of m. So this is in this formula, if you are multiplying n into m, again if you simplify this one, this expression, if you simplify this expression, what will happen? 2 will be cancelled with 2. When you multiply m with n minus 1, it will be mn minus m plus m. Minus m and plus m will be cancelled and you will left again with n into m. Is it clear? So actually in this technique we are just converting any number into the form of table of 2. Either we are reducing, making it half, or we are multiplying it by 2. So only remembering the doubling and halving technique, you will easily calculate the result. Is that clear? And this is the base case. If n equal to m, then the result will be m. So when you are keep on reducing n, one time will come when n become 1. Is that clear? So definitely you will get the result of m. So it can be solved in a recursive way. Any doubt about this technique? Any question? Okay, now see an example how these formula can be used to multiply to larger integer. Suppose we have two variables n and m, and values of n and m is 50 and 65. So if n is even, you will use this formula. If n is odd, you will use this formula. So here n is 50, which is even. So how you will multiply it? You will you make half of n and double m. So n will become 25 and m will become 130. Is it clear? Now again, see, now n has become 25. 25 is odd. So we will apply this formula. If you reduce 1 by n from n, it will be 24 and divide it by 2. So answer will be 12. So it is very easy to make it half. It will be 12, and if you double this 130, it will be 260. And we have to add here a new value m according to formula. So m was 130. Addition can easily done. So 130 will be added to this result. Is that clear? Now further reduce n by 2 because it is even. So it will become 6 and 260 will be multiplied by 2, that will be 520. Again 6 is even, so we'll reduce, it will be 3, and if you multiply this 520 it will be 1040. Again 3 will be reduced, it is odd, so 3 minus 1, that will be 2, 2 divided by 2 will be 1, and double m, if you double 1040 it will be 2080 plus m, and m was 140. Is that clear? So now if you reduce, now n is 1, if n is 1, answer will be 2080. Now you will add these all values which is added. So 2080, 130 and 140. If you add them up, the answer will be 3250, which is actually the multiplication of 50 and 65. Is that clear? So rather than multiplying this big number 50 into 65, you keep on halving or doubling the value. And whatever the extra value comes, that will be added together to get the result. So it will make the multiplication of larger number easier. Is that clear? Now coming to the next problem, decrease by constant. I will explain the general formula only and the background of this problem, and I will leave it to apply these formula and to find the solution for it. Okay. So this algorithm actually invented by a Jewish army general whose name was Flavius Josephus. They were actually fighting against the Romans, and after fighting and losing the war, they were trapped in some place in a jungle. He was very intelligent person. He said, we will sit in a circle, and every person will kill his neighbor. Okay, and whoever left whoever left, that will be the person who can go from here. Okay, so if we have n person, they will be labeled from 1 to n in a circle, starting the count with the person number 1, and we eliminate every second person until only 1 is left. That will be declared as a survivor. Now this is up to them how they will place each their location, and once they are settled down, then they will start from 1 and he will kill the neighbor 1. Is it clear? What was the game? Okay, so he invented the formula and he placed himself at such a location that he survived with one other person, and both person were then run away and they saved their self. So this was the formula which they have used, that if n is even, then your location must be 2jk minus 1. This will give you a value at which you must place yourself depending on number of persons in that group. And if n is odd, then use this formula to place yourself. 2jk plus 1. And if you have only one, that is you are the survivor. Is that clear? So this was a formula which is used to find the survivor, and the solution for n equal to 6 that is mentioned here. If n is 6, the survivor will be 5. The person who is standing at location 5, that will survive. So if we are numbering like 1, if this is 1, 2, 3, 4, 5. The first person who will be killed is 2. Okay? Every second person will be killed. So next one will be this one. Okay? Next one will be this one. And next one will be this one, and then it will left with 5. You can keep on calculating this value. Okay? So similarly, two examples has solved here with n equal to 7. The person who is standing at number 7, he will survive. So verify these results using this formula. This is your exercise, and inshallah we will start the next portion, decrease by variable size, in next from next time. Okay. So today you have two exercises. One is you have to apply this formula and find the survivor for any number of n. Two examples are solved, and you can choose any random number n and see who will be the survivor for those number of people. And the second was related to fake coin problem, that if you have 3 groups, you can make 3 groups, then how you will select the survivor. Is it clear? So if you have any question till now, you can ask me, otherwise I will mark your attendance now.